So, today what we're going to talk about is completing the square. I'm going to begin my lecture with talking about what a perfect square trinomial looks like. A perfect square trinomial is any trinomial that can be factored into a single factor. An example of this is x minus n quantity squared. This is a perfect square trinomial in the factored form. Now, what I'd like you to notice is I'm going to expand this out just using the property of my exponents to start with. That squared says that this is x minus n times x minus n. So, on my right side, I have it in the factored form, and on the, in the left side, we have it in the factored form. On the right side, I am going to expand it out. So, leaving the left side alone, on the right side, I will factor using FOIL. Okay. Again, the left side I am leaving alone. I will combine like terms on the right side. So, on the right side, what you see is the perfect square trinomial fully expanded out. So you got three terms, that's what makes it a trinomial. On the left side, what you see is the factored form. It's the exact same object. So if you can visually identify the object on one side, you can automatically write it on the other side. An example. If, for instance, you saw something written like this. You should automatically recognize that this is a perfect square trinomial. It has the perfect form x squared minus 2 times some number times x plus that number squared. And that number happens to be a positive 3, which means I can immediately put it in the factored form, and the factored form right here is x minus that number squared. So if I can identify that it is a perfect square trinomial, I can immediately write it in the factored format as long as I have identified the number n. So what I will do from here is look at things that take a little bit more work to identify that number. For instance, if this was expanded out, it would look very different. If it had been written in the simplified form, it would have looked like that. X squared minus 6x plus 9. It's the same object, but now we have to figure out how would we identify that number. Well, we start the process every single time by looking at the number in front of the x. Notice, when I have the generic formula, the number in front of the x is described as negative 2 times n. If I look at this trinomial and I let negative 2n equal negative 6, then I can identify the number as 3. We will always use negative 2n as the number in front of my x term. If it is a perfect square trinomial, it must be always negative 2n. Now, the question becomes, do you have the n squared? If we do, then you have a perfect square trinomial and you've identified the number n. If you have a perfect square trinomial and have identified the number n, you may write it in the factored form, x minus n quantity squared. So let's look at a couple of examples and identify, first of all, if we have a perfect square trinomial or not. And if we do have a perfect square trinomial, we will put it in the factored form. So here's how I will start the process. If I have a perfect square trinomial, this number in front of the x is negative 2 times the number I am looking for. Now I will find that number by dividing both sides by negative 2. Now, to have a perfect square trinomial, the very last number must be that n squared. So, do we have n squared? Yes, then I can write this in the factored form. The factored form of this trinomial is x minus n, quantity squared. So the question is, once we find the number, are you guaranteed to have that 25 there, the number squared? The answer is no. So what do we do if the number's not there? What we're going to talk about next is called the technique of completing the square. Completing the square is where we generate that number. So let's take a look at an example of completing the square. First, we'll start without equations. Let's take a look at this. Right now, I only have two terms, x squared plus 12x. I would like to make a perfect square trinomial. I do not have a perfect square trinomial. So to create this perfect square trinomial, I need to find that missing number. So let's talk about that missing number. That missing number will be found by taking the number in front of x and letting negative 2 be the number in front of x. That means the number I am looking for is negative 6. Then n squared is not 12, it is 36. So what I am missing is a positive 36. When I put that positive 36 in there that was not there before, we call this technique completing the square. Yes, ma'am?
Mr. Since it's n squared, the last number is always going to be positive.
Yes, the last number will always be positive in this format. And now that we've completed the square, I can put it in the factored format. X minus n, but notice n is negative 6, squared. So this is the technique of completing the square by finding the missing term and then putting it in factored format. Now we will use this technique to solve equations.
Why are there 5 mistakes?
Because I am subtracting a negative number. See, that's negative there? And anytime you subtract a negative number, I end up with addition. Okay, where would we use something like this? Here is a quadratic equation. To solve a quadratic equation, the same thing I need to do for any other equation. I need to, basic rule of thumb, get rid of fractions if you have any, if it's possible and convenient. Simplify whenever possible and convenient. Get your unknown x on one side of the equation written in one location. The problem is my unknown x is written in two separate locations. I'm going to get it to one location by using the completing the square technique. So to solve this equation, what I'd like to do is identify the number I'm looking for, and I'm going to let negative 2n be that number, and it equals 2, which means that n equals negative 1, n squared equals positive 1. Now, this situation is a little bit different because I have an equation. If I add 1 to this side of the equation, I must also add 1 to the other side. Now, on the left side, we have a perfect square trinomial. I can write that perfect square trinomial as x minus n, and since I have a negative n, when I subtract a negative, becomes positive squared equals positive 1. So I completed the square, I wrote it in the factored format, and now I have met my objective. I have x written on one side of the equation in one location, which means I can remove everything away from x. The very first thing I will remove away from x is any addition and subtraction outside the parentheses. I don't have any. I will remove multiplication and division outside the parentheses. I don't have any. I will remove the exponents outside the parentheses. I have an exponent of 2. I can either use a rational exponent of 1/2, or I can express it with a radical. For the purpose of this class, I'm going to express it with a radical. So I'm going to take the square root of both sides. However, whenever I take the square root of both sides, I will always end up with a plus or minus in front of that square root. There's two separate possibilities. Now, 1 is a perfect square, so I can simplify the right-hand side. The square root of 1 is 1. So I have two possible answers. X plus 1 equals negative 1, or x plus 1 equals positive 1. I'm going to solve both of those equations independently. First equation, I'm going to subtract 1 from both sides. Other equation, again, I'm going to subtract 1 from both sides to isolate x. And now I have two separate answers. Possible answers are negative 2 and 0. So this is an example of using the completing the square technique to solve a quadratic equation. I will do one more example of using the completing the square technique. Okay, I would like to use the completing the square technique to solve this equation. For me to do that, the first thing I need to do is get rid of the third term that's in the way. I want to get down to 2 terms so that I can complete the square on those 2 objects. So, step 1, get rid of the minus 7 by adding it to both sides. Another small problem I have is the 2 in front of the x squared. If I have a 2 in front of the x squared, I'm going to remove it by dividing each and every object by 2. So, everything is going to be divided by 2. And I will end up with x squared minus 4x equals 7 halves. Now, what I have on the left-hand side has a 1 in front of the x squared. It only has 2 terms. That I can complete the square on. To complete the square on the left-hand side, I'm just going to put a line here to do my work over here. I'm going to let negative 2n equal negative 4. Back to that number. Then n must equal negative 4 divided by negative 2, and n squared is 4. So now I have the object I need to complete the square on my left-hand side. I will complete the square by adding that 4 to both sides. Now, when I add the 4 here and here, I'm going to rewrite that 4 as 8 halves so that I can add those two fractions together. Common denominator. You may use your calculator to handle the fractions if you'd like. So, I'm now going to write this object in the factored format. X minus my n value, quantity squared, equals 8 plus 7 is 15 over 2. Now, I can, oh yes sir.
I thought you were supposed to plug in 4 instead of 2.
Well, I did plug in 4, I added 4 to both sides. However, the perfect square trinomial factors to x minus n, not the n squared. So this, bringing the 4 on this side is what makes it perfect square, but it's always going to factor. So I need to bring this in, but it factors to x minus the n. So basically I'm using both of those numbers. Now, I'm going to solve this equation. The first step I need to do is remove that exponent of 2. I'm going to do that by taking the square root of both sides, leaving me with x minus 2 equals plus or minus the square root of 15 halves. I'm now going to solve for x by adding the 2 to both sides. Now, I don't want to get confused whether that 2 is under the radical or not under the radical. To avoid that confusion, we're going to put that positive 2 out front. So I end up with x equals 2 plus or minus the square root of 15 halves. Right, to move the 2 from the left-hand side to the right-hand side, I added the 2 to both sides. And that concludes the examples for completing the square.